the world right now, something massive is happening behind the scenes, something most people will never see, but everyone will feel. Data centers, once quiet back office facilities, are transforming into the industrial engines of the AI era. These buildings aren't just storing data anymore, they're powering intelligence, they're driving automation, they're shaping economies, and they're consuming energy, materials, and infrastructure at a scale we've never experienced before. AI has changed the rules. Training a single advanced model can draw more power than a small town. Cooling systems are evolving from simple HVAC to liquid and immersion technologies. Robotics, digital twins, and autonomous controls are becoming standard. And nations are now competing, not for oil, not for steel, but for compute capacity. In today's episode, we're going to explore why AI-driven data centers are quickly becoming the new industrial infrastructure. What's changing under the hood, what pressures they're putting on global systems, and why every industry, from energy to manufacturing to protective coatings, needs to understand this shift. Because the future of AI isn't just digital, it's physical, and it's being built right now. Why data centers are becoming the new industrial backbone. To understand why AI-driven data centers are becoming the new industrial backbone, we have to start with one simple truth. Artificial intelligence has changed the physics of computing. The workloads required to train and run modern AI models are orders of magnitude larger than anything the cloud was originally designed for. We're no longer talking about simple storage or transactional processing. We're talking about massive parallel compute, high-density GPU clusters, and energy demands that rival heavy industry. And that shift is transforming data centers from quiet digital warehouses into mission-critical infrastructure. Every major AI breakthrough, from large language models to autonomous systems, requires enormous computational power. And that power has to come from somewhere. As a result, data centers are expanding at a pace we've never seen before. Hyperscale facilities are being built near power plants, near renewable energy hubs, and in regions where grid capacity can support them. Nations are treating compute capacity the way they once treated oil reserves or steel production. It's becoming a strategic asset, a competitive advantage in the global economy. But it's not just the scale that's changing. It's the role data centers play in society. These facilities now support everything from financial markets to national security to industrial automation. They were the backbone of logistics, manufacturing, healthcare, and energy. When an AI model predicts pipeline corrosion, optimizes a refinery, or manages a smart grid, the intelligence behind that decision is running inside a data center. In other words, the physical world is increasingly dependent on digital infrastructure, and that digital infrastructure is increasingly dependent on AI. This is why industries far outside of tech, manufacturing, materials science, construction, utilities, and asset integrity, suddenly find themselves connected to the data center conversation. These buildings are no longer simple IT assets. They are high-heat, high-load, high-risk industrial environments. They require advanced cooling systems, specialized materials, corrosion-resistant coatings, and rigorous inspection practices. They operate like factories that produce intelligence instead of physical goods. So when we say data centers are becoming the new industrial backbone, we're not speaking metaphorically. We're describing a real shift in how global infrastructure is built, powered, protected, and maintained. AI has pushed data centers into the center of the industrial world. And as demand continues to grow, every sector, from energy to manufacturing to transportation, will feel the impact. What's changing under the hood? To understand the rise of AI-driven data centers, we need to look at what's happening inside these facilities. because the transformation is dramatic. Traditional data centers were built around CPUs, predictable workloads, and relatively stable thermal and power profiles. But AI has blown that model apart. Today's data centers are being redesigned from the ground up to support high-density GPU clusters, accelerated computing, and nonstop machine learning operations. The architecture is shifting from static and reactive to dynamic and autonomous. One of the biggest changes is cooling. The heat generated by modern AI hardware is far beyond what legacy air cooling systems were designed to handle. That's why we're seeing rapid adoption of liquid cooling, cold plates, and even full immersion cooling. These technologies allow data centers to pack more compute into smaller footprints while keeping temperature stable. And because AI workloads spike unpredictably, cooling systems now rely on real-time analytics and automated controls to adjust flow rates, temperatures, and energy use on the fly. Power distribution is undergoing a similar evolution. AI clusters draw enormous amounts of electricity, often in short, intense bursts. To manage this, data centers are deploying AI-driven energy management systems that can predict load patterns, optimize power routing, and reduce strain on the grid. Some facilities are even integrating on-site generation, battery storage, and advanced UPS systems to stabilize operations. The goal is simple: keep the compute running no matter what. Automation is also becoming a defining feature. Robotics are being introduced for tasks like hardware swaps, cable management, and environmental monitoring. Sensors track everything from airflow to vibration to micro temperature fluctuations. And digital twins, virtual replicas of entire data centers, allow operators to simulate failures, test upgrades, and optimize performance without touching physical equipment. These tools turn data centers into self-observing, self-adjusting environments. And then there's workload orchestration. AI models don't run like traditional applications. They require massive parallelization, precise scheduling, and intelligent resource allocation. Modern data centers use AI to manage AI, optimizing compute clusters, balancing workloads across regions, and predicting when hardware will need maintenance. This level of orchestration is what enables hyperscale facilities to operate efficiently at global scale. So when we talk about AI-driven data centers, we're not just talking about bigger buildings or faster servers. We're talking about a complete reinvention of how digital infrastructure is designed, powered, cooled, and managed. These facilities are becoming living systems, constantly sensing, learning, and adapting. And that shift is redefining what it means to operate at the frontier of the digital world. The industrial impact, energy, materials, and infrastructure. When we talk about AI-driven data centers becoming the new industrial infrastructure, the impact goes far beyond technology. These facilities are reshaping how regions plan energy, how companies design physical assets, and how governments think about long-term infrastructure strategy. The scale of AI compute demand is forcing a re-evaluation of everything from power generation to water usage to land development. In many ways, data centers are becoming one of the most influential forces in modern industrial planning. Let's start with energy. AI data centers are now among the fastest growing consumers of electricity worldwide. A single hyperscale facility can draw as much power as a manufacturing plant or a small city. And because AI workloads fluctuate rapidly, they create unique challenges for grid stability. Utilities are being pushed to expand capacity, modernize transmission lines, and integrate more renewable sources. Some regions are even adjusting long-term energy policy to attract or support data center development. This isn't just a tech trend. It's a shift in how nations think about energy security and economic competitiveness. Water usage is another major factor. Advanced cooling systems, especially liquid and evaporative cooling, require significant water resources. This is driving data center operators to rethink site selection, sustainability practices, and environmental impact. In water-stressed regions, companies are exploring alternative cooling technologies, closed-loop systems, and even wastewater reuse. The pressure to balance performance with sustainability is pushing innovation in ways that ripple across multiple industries. And then there's the physical footprint. Data centers require specialized buildings, high-capacity substations, fiber connectivity, and access to transportation infrastructure. This has created new industrial zones, new construction demands, and new regional development strategies. Some cities are embracing data centers as economic engines, while others are grappling with the strain they place on local resources. Meanwhile, the rise of edge computing, smaller data centers placed closer to users, is distributing this infrastructure across more locations, from urban centers to remote industrial sites. All of this creates a cascading effect across the broader industrial ecosystem. Manufacturers must adapt to supply the hardware, cooling systems, and materials needed for next-generation facilities. Energy providers must plan for unprecedented load growth. Construction and engineering firms must design buildings capable of supporting extreme density and automation. And policymakers must navigate the balance between economic opportunity and resource management. In short, AI-driven data centers are no longer just part of the digital economy. They are shaping the physical economy. They influence how we build, how we power, how we allocate resources, and how we plan for the future. Their impact is industrial, infrastructural, and global. And as AI adoption accelerates, that impact will only grow. Risks, challenges, and the road ahead. As AI-driven data centers continue to expand, it's important to recognize that this growth doesn't come without challenges. In fact, the rapid acceleration of AI infrastructure is creating a new set of risks: technical, environmental, economic, and even geopolitical. These aren't hypothetical concerns. They're real pressures that governments, utilities, and technology companies are already wrestling with. One of the biggest challenges is energy. AI workloads are unpredictable and extremely power intensive, which puts strain on electrical grids that were never designed for this level of demand. Some regions are already facing delays in data center construction because the grid simply can't support additional load. This creates a tension between innovation and infrastructure readiness. And as AI adoption grows, that tension will only increase. Another major challenge is supply chain pressure. The components required for AI data centers, GPS, advanced cooling systems, high-density power equipment, are in global demand. Lead times can stretch for months or even years. This creates bottlenecks that slow deployment and increase costs. And because AI hardware evolves so quickly, companies face the constant risk of building facilities around technology that may become outdated faster than expected. Security is also a growing concern. As data centers become more automated and interconnected, the attack surface expands. Cyber-physical security, protecting both the digital systems and the physical infrastructure, becomes critical. A breach in an AI-driven data center isn't just a data problem. It can disrupt essential services, industrial operations, and national systems that depend on continuous compute availability. And finally, there's the challenge of sustainability. Communities and regulators are increasingly focused on the environmental impact of large-scale data centers, from energy consumption to water usage to land development. Operators are under pressure to innovate, to reduce their footprint, and to demonstrate that AI infrastructure can grow responsibly. The future of data centers will depend not just on performance, but on public trust and environmental accountability. So as we look ahead, the road forward is both exciting and complex. AI-driven data centers will continue to expand, evolve, and redefine global infrastructure. but their success will depend on how well we navigate these challenges, how we balance innovation with responsibility, growth with sustainability, and ambition with resilience. The next decade will determine not just how data centers operate, but how the digital world and the physical world coexist. Episode closing thoughts. What this means for industry leaders. As we step back and look at the full picture, one thing becomes clear. AI-driven data centers are no longer just part of the digital ecosystem. They are becoming the backbone of modern civilization. Every sector, every service, every innovation that relies on AI ultimately depends on the strength, resilience, and intelligence of these facilities. They are the new industrial infrastructure shaping how economies grow, how organizations operate, and how societies function. For leaders across every industry, this shift carries a powerful message. Understanding data centers is no longer optional. It's not just a topic for IT teams or cloud architects. It's a strategic priority. The decisions being made today about energy, automation, sustainability, and digital capacity will influence competitiveness for decades. And the organizations that recognize this early, the ones that understand how AI infrastructure is evolving, will be the ones best positioned to thrive in the next wave of digital transformation. The future of AI isn't abstract. It's not theoretical. It's being built in real buildings, drawing real power, using real resources, and shaping real-world outcomes. And as these data centers continue to grow in scale and sophistication, they will redefine what it means to operate in a digitally driven world. The leaders who stay informed, stay adaptable, and stay curious will be the ones who navigate this transition with confidence. And with that, we wrap up today's episode of The Digital Revolution with Jim Kunkel. I want to thank you for spending your time with me, for your continued support, and for being part of this growing community of professionals who are passionate about understanding the forces shaping our digital future. Whether you're a longtime follower or tuning in for the first time, I appreciate you. Your engagement, your curiosity, and your commitment to learning are what make this podcast possible. If you enjoyed this episode, make sure to follow the show on your favorite podcast platform so you never miss what's coming next. Until then, stay informed, stay innovative, and keep leading the way in this digital revolution.